So now we're going to look at chronic responses that occur as a result of aerobic training, and this is the really important ones. So you have to think, what is the main aim of aerobic training? Basically, aerobic training is about improving the cardiorespiratory system, essentially all about enhancing the delivery of oxygen to the working muscles. How can we get more oxygen to our working muscles? So we're going to be looking at our respiratory system and our circulatory system. What are the changes, what are the adaptations that happen to those body systems, and even the muscular as well, to allow better oxygen uptake, better oxygen delivery, and better oxygen extraction, so we're getting more oxygen to the working muscles. So the first one we're going to look at is cardiac hypertrophy. So just as we looked at before with skeletal muscle hypertrophy, our heart muscle can also get bigger and larger when we exercise. So particularly the size and volume of the left ventricle is going to enlarge because it's going to be pumping more oxygenated blood around the body. You can see here's the normal heart compared to a trained athlete's heart. And the left ventricle here, remember the blood comes into the right side of the heart, goes to the lungs, and then comes back to this left side, which pumps it to the body. You can see that the whole left ventricle, right here, if you look at the muscular tissue, is much smaller compared to the thicker, stronger muscular tissue around the left ventricle of the trained athlete. So this means that this heart's going to be able to pump more blood per beat. So we get an increase in stroke volume, and when we're exercising at maximum intensities, we're going to get an increase in cardiac output, the amount of blood pumped from the heart per minute. And so just showing you that picture there again. And like I said, this is going to result in more blood pump per beat, so we get an increase in stroke volume, and therefore more oxygen is going to be delivered to the working muscles in a minute. We can calculate that by our increase in cardiac output. And cardiac output, remember, is calculated by our stroke volume of blood pumped per beat, times by our heart rate, which is the number of beats per minute, to get the total amount of blood pumped from the heart per minute. So here we can see the increased cardiac output at maximum workload. So this is comparing trained to untrained. So here we've got our cardiac output in litres per minute. So remember, stroke volume and the heart rate times together. And you can see at rest, it's about 5 litres per minute. But when we're exercising at maximum intensity, you can see males and typically have untrained males are able to produce 20 to 22 litres per minute, and females 15 to 16. Remember, males and females are going to be different here. So you can see the untrained cardiac output here is sort of average there at about 23 litres per minute. Whereas with training, the values can be improved to about 30 litres per minute. So that means we're going to have a greater volume of blood pumped from the heart at maximum workloads. So in going on from cardiac hypertrophy, so a trained athlete is also therefore going to have a lower resting heart rate. So the effect is that the heart essentially doesn't have to beat as much, so it can beat less to achieve the same result. So fewer beats for the same output. This is at rest. So remember, at rest our stroke volume has increased because our heart can pump more blood per beat, and therefore it doesn't have to pump as often when we're at rest to supply the same amount of blood around our body. This is why often trained athletes will have those lower resting heart rates. It's also important to remember the heart rate of a trained athlete, it can therefore return to resting levels much shorter, so we get better recovery time compared to our untrained athletes. So here's a graph here just showing the heart rate responses before, during and after submaximal exercise. So this is medium intensity with a trained and untrained athlete. So you can see here here is our untrained athlete in red and our trained is in blue. You'll notice that the untrained athlete's resting heart rate is much higher compared to the trained athlete. You'll notice that during the medium intensity, their heart rate goes much higher as well. This is because it's needing to pump faster because it's not as efficient. The trained athlete's heart is bigger and therefore can pump more blood with less beats. And then so that's during the work, and then once we stop the exercise, the recovery is much quicker for the trained athlete compared to the untrained athlete. So with this might also impact, we can see a lower blood pressure in trained athletes, so particularly their systolic blood pressure value, which is the blood pressure as the heart contracts and squeezes the blood out. This is because we've got enhanced oxygen delivery and better efficiency of the heart. Basically, chronic adaptations, we're definitely not going to really see high blood pressure. So what does all this mean? So through training, our heart does not have to work as hard for the same results. Our bigger, stronger heart is able to provide more oxygen to the working muscles with less effort. So greater volume of blood is pumped by the heart with less beats required. This means the athlete can use the oxygen energy system for a longer period of time and at higher intensities, thus improving their performance as there's less reliance on the anaerobic system. So it's all about how can we get more oxygen to the working muscles, and a bigger heart does this, and therefore we don't have to rely on our anaerobic energy systems at those higher intensities. So let's summarize here. I've got a little flow chart. So cardiac hypertrophy, bigger, stronger heart, is going to mean there's going to be a greater volume of blood pumped from the heart, so we get an increased stroke volume. This is going to mean that we've got more oxygen delivered to our working muscles, and therefore we can use the aerobic energy system at higher intensities, and we have less reliance on those anaerobic energy systems. We know that when we start relying on anaerobic energy systems, that's when fatigue can set in and that's when performance can be affected.